Hi guys! Welcome sa enginerdmath channel. Sa video na to ay tuturo ko sa inyo ang apparent power and power factor. So kung gusto niyo itong matutunan, just keep on watching. Okay, so this time ay tuturo ko naman sa inyo ang apparent power and power factor. Okay, so still topic pa rin natin to for AC circuits kung saan kino-consider natin is AC power analysis. So meron na akong previous videos about introduction to AC power analysis. So na yung pinapapanood, isilink ko na lang para ma-check nyo. Okay? So far for AC circuits ay na-discuss ko na yung instantaneous power as well as yung average power. So ngayon is i-discuss naman natin kung ano ba yung apparent power and power factor. Okay, so we already know that the time domain representation of the voltage and current at the terminals of a circuit are, so V of t is equal to V sub m times cosine omega t plus theta v, and I of t is equal to I sub m cosine omega t plus theta I. Or in phasor form, V is equal to V sub m angle theta b, and I is equal to I sub m angle theta I. So ito na nga yung mga na-discuss ko so far sa AC circuits natin. So, yung time domain representation ng ating voltage at current as well as yung phasor form. Now, na-discuss na rin natin na yung average power is given by P is equal to 1/2 V sub m I sub m cosine theta v minus theta I. So, itong average power natin is measured in watts. Okay? Or in terms of the RMS voltage and current, we have P is equal to VRMS, IRMS, cosine theta V minus theta I. So, itong 1/2 V sub M, I sub M, pinalitan lang natin ng RMS representation nila. Kasi dito, di ba, peak current tsaka peak voltage yung given. So, kapag ginawa natin yung average power in terms of VRMS tsaka IRMS, base dun sa video ka about RMS voltage and current, right? Ito yung other formula natin for average power. Okay? Now, pwede nating i-represent itong product ng VRMS saka IRMS into a variable S, such that yung power natin, yung average power is equal to S times cosine theta V minus theta I. So, itong S na in-equate natin as VRMS times RMS, ito yung tinatawag natin ngayon na apparent power. Or this time, ang kanyang unit ay hindi na watts, kundi volt ampere. Okay? So, later on kasi, itong apparent power, malalaman natin na siya yung pinaka-complex power natin. Magkakaroon tayo ng real power tsaka reactive power. Itong dalawang components na to ng power, yung bumubuo dito sa pinaka-complex power natin or itong apparent power. Okay? Now, kapag power factor naman, it is equal doon sa cosine theta V minus theta I. So, dito sa P is equal to S times cosine theta V minus theta I, itong cosine ng theta V minus theta I o yung phase difference doon sa angle at voltage, siya yung tinatawag nating power factor. Okay? So, dimensionless siya. Tapos, pwede rin natin tong ma-compute as the ratio nitong P over S. Kasi nga, ito yung formula natin for average power. Pag divide natin both sides by S, magiging ratio siya ng P to S. Ratio ng average power to the apparent power. Or cosine theta V minus theta I. Okay? So, itong power factor, siya yung magdedetermine kung how much doon sa apparent power yung nagagamit natin as the average power or the true power. Kasi yung average power, measured siya in watts, right? So, parang siya yung pinaka-real power na nako-consume natin. Okay? So, parang itong power factor is nagde-dictate kung gaano ka-efficient yung isang circuit in terms of the loadings. Okay? Kung how much doon sa complex or apparent power yung pinaka nako-consume natin as average or real power base doon sa power factor ng circuit. Okay? So, yung phase difference, theta V minus theta I between doon sa current at voltage ay tinatawag nating power factor angle. At kapag hinanap natin yung cosine niya, yun na yung pinaka power factor. So, sabi, the power factor is the cosine of the phase difference between the voltage and current. It is also the cosine of the angle of the load impedance. Okay? So, pwede rin nating ma-equate itong phase difference na to na theta V minus theta I doon sa angle ng load impedance, which is denoted by Z. So, using Ohm's law, we have Z is equal to V over I, or yung voltage at current doon sa isang circuit. So, pag ginawa nating phasor form, we have V is equal to V sub M angle theta V over yung I in phasor form I sub M angle theta I, or V sub M over I sub M is equal to theta V minus theta I, applying division for complex number in polar form. Or since VRMS is equal to V over square root of 2, or VRMS angle theta V, IRMS is equal to I over square root of 2, or IRMS angle theta I, pwede nating i-write itong impedance Z is equal to V over I is equal to VRMS over IRMS equal to VRMS over IRMS angle theta V minus theta I. So, in terms of RMS voltage at current, ito yung other formula natin for the impedance. So, as we all know, meron tayong impedance triangle, right? Okay? Kung saan meron tayong resistance measured in ohms at meron tayong reactance measured in ohms din. Let's say X. Okay? So, yung dalawang legs na to, yung component ng impedance, yung resistive tsaka reactive component, and then yung hypotenuse, yung pinaka-impedance. And then, meron tayong angle theta dito to denote the angle of the impedance. Okay? So, itong theta na to, yung theta ng load impedance, kapag hinanap natin yung cosine niyan, equal din siya sa power factor. Okay? Note daw that the power factor may be seen as that factor by which the apparent power must be multiplied to obtain the real or average power. Okay, so from the formula, right? So, yung real or average power is equal to S times power factor. So, kapag multiply natin yung pinaka-apparent power dito sa power factor, makukuha natin yung average power or real power. So, yung power factor range is from 0 to 1. Okay, so 0 to 1 yung pinaka-magiging acceptable value ni power factor. Tapos, meron tayong different conditions. So, if theta V minus theta I is equal to 0, therefore, theta V is equal to theta I. So, parang wala silang phase difference, right? So, in other words, purely resistive yung circuit natin. Kapag ganon, yung power factor natin is power factor is equal to cosine dahil yung theta V minus theta I is 0, cosine 0 degree, or equal to 1. So, ito yung pinakamataas na power factor natin, right? Kasi from 0 to 1 yung power factor. Kapag ganito yung case natin na yung power factor is 1, yung average power natin is equal doon sa apparent power. So, ibig sabihin, so lahat ng power natin dito sa AC circuits is real or totally nako-consume or na-absorb ng ating load. Okay, so P is equal to S, which is in this case maganda, right? So, tandaan nyo, kapag mataas yung power factor, mas maganda siya kasi mas mataas ang magiging real power natin. Okay? And then, we have also another case if the phase difference or theta V minus theta I is either equal to plus minus 90 degree, so purely reactive. So, ibig sabihin, wala tayong resistance, kundi either capacitive or inductive load. So, in this case, kapag positive 90 degree, inductive, or ibig sabihin, yung current natin lags the voltage by 90 degree. So, laging power factor yung tawag doon. Okay? Kapag negative 90 degree naman, meron tayong capacitive load or yung current natin is nagli-lead sa voltage by 90 degree. Okay? So, meron tayong leading power factor doon. Okay? So, in either case, either inductive or capacitive or purely reactive, yung magiging value ng power factor natin is cosine plus minus 90 degree or 0. Ibig sabihin, wala tayong na-absorb na real power. 0. Which is in this case is pangit. Kasi sabi ko nga, mas advantageous kapag mataas yung power factor natin. Okay? So later on, pag-aaralan natin kung paano makorek or mapataas yung isang power factor ng given circuit by altering or adding additional load doon sa circuit. Particularly capacitive loading kasi nagpapataas yon ng ating power factor. Okay? So, ito yung extremes value ng ating power factor, purely resistive at purely reactive. So, 0 and 1. So, kapag meron tayong impedance triangle kung saan meron tayong combination nga ng resistance saka reactive component ng impedance, pwede nating matimpla yung range ng value ng ating power factor between 0 and 1 using the theta. Okay? Pag kinosay natin yung theta ng impedance triangle is, yun yung magiging value natin ng ating power factor. Okay? So, para ma-illustrate natin yung na-discuss nating concepts at formula for apparent power at power factor, ay mag-solve tayo ng examples. So, for the first one, we have a series connected load draws a current I of t is equal to 4 cosine 100 pi t plus 10 degree amps when the applied voltage is V of t is equal to 120 cosine 100 pi t minus 20 degree volts. Find the apparent power and the power factor of the load. Determine the element values that form the series connected load. Okay, so this time meron daw tayong AC circuit na merong current na nagpa-flow. So, I of t is equal to 4 cosine 100 pi t plus 10 degree amp. Tapos, yung voltage supplied is 120 cosine 100 pi t minus 20 degree volts. Okay? So, ito lang yung given natin. So, hanapin daw natin yung apparent power and power factor. Okay? So, mapapansin nyo, nasa time domain representation tayo. So, ibig sabihin nitong 4, sa current, siya yung peak current natin. So, IM equals 4. Tapos, sa voltage, itong 120, siya yung peak voltage natin na 120 volts. Okay? So, meron tayong formula kanina, right? Na yung apparent power is equal to VRMS times IRMS. Right? Kaso, yung given natin is I peak tsaka V peak. Pero, meron tayong relationship na yung IRMS, base dun sa video ko sa effective voltage at current, na equal sa IM over square root of 2. Same dito sa VRMS, equal siya sa VM over square root of 2. So, pwede natin i-plug in ngayon dito. So, yung IRMS is equal to ano yung IM? 4. 4 over square root of 2. Then, yung VRMS, VM over square root of 2. So, ano si VM? 120 over square root of 2. So, using calculator, 4 over square root of 2 times 120 over square root of 2, we have 240 VA, volt ampere, right? Then, ano naman yung power factor? So, mapapansin nyo, given naman tayo ng phase difference dun sa time domain. So, yung theta I natin is positive 10 degree, right? And then, yung theta V natin is negative 20 degree. So, mapapansin nyo, dahil negative yung phase angle nitong voltage at positive yung phase angle ni current, nagli-lead yung current doon sa ating voltage. So, therefore, ang expect natin is capacitive yung ating power factor or leading, right? Base dun sa concept ko kanina. So, pwede nating mahanap yung power factor as equal dun sa cosine ng phase difference, right? So, theta V minus theta I. So, cosine ng ano yung theta V, negative 20 degree, minus ano yung theta I, 10 degree. So, we have cosine of negative 30 degree. So, using calculator, ilan ito? 0.866. So, dahil capacitive nga, leading power factor. Okay? So, ito yung power factor natin tsaka apparent power. Now, determine the element values that form the series connected load. So, hanapin daw natin yung pinaka-load. Kasi yung given lang is yung current tsaka yung voltage. So, using yung formula natin for impedance, right? Z is equal to V over I. So, meron naman tayong given na current tsaka voltage. So, gawin na lang natin tong phasor form. So, yung current is 4 angle 10 degree. So, ito si current. Si voltage is equal to 120 angle negative 20 degree. Right? So, therefore, substituting dito sa impedance formula, we have V is equal to 120 angle negative 20 degree over 4 angle 10 degree. So, 120 divided by 4 is 30. And then, yung angle is negative 20 degree minus 10 degree or 30 angle negative 30 degree. So, using calculator, input natin to. So, gawin nating rectangular form para makuha natin yung pinaka-resistive at reactive components. So, anong makakompute natin dito sa calcu in complex mode? 25.98 minus J15 ohms. Okay, so therefore, yung resistive component ng impedance is 25.98 ohms, tapos yung reactive component niya is negative J15 ohm. So kapag negative, di ba, ibig sabihin noon meron tayong capacitor. So ibig sabihin capacitive yung ating impedance. So ibig sabihin meron tayo agad na series resistor tsaka capacitor. So yung resistor, alam natin na yung value niya is 25.98 ohms, right? Para naman dito sa capacitor, kunin natin yung capacitance niya. So, di ba, ang formula natin for the reactance ng capacitor is 1 over 2 pi f. Okay, XC. So, equate natin. So, 15 is equal to 1 over 2 pi f. Okay, ano yung f natin? Given tayo dito sa circuit na yung omega natin is 100 pi, right? Kasi cosine omega t yung equivalent nito. So, substituting this value, omega, so itong ating omega is equivalent siya sa 2 pi f, right? So, we have 1 over 2 pi f, kulang pa tayo ng c, right? Yung formula natin for impedance ng capacitor is 1 over 2 pi fc. So, yung 2 pi fc is omega na. So, 1 over, aning omega? 100 pi. C is equal to, yung nakuha nating reactive component ng impedance is 15. Equate natin sa 15 so that C is equal to 1 over 100 pi times 15. So, using calculator, ano ito? 212.2 microfarad. So, therefore, ito yung ating series connected load. Capacitor with value 212.2 microfarad and a resistor with value 25.98 ohms. Okay? Next, we have determine the power factor of the entire circuit of figure below as seen by the source. Calculate the average power delivered by the source. Okay, so this time, given tayo ng pinaka-easy circuit natin. So, meron tayong voltage source na may value na 30 angle 0 degree, this time VRMS. Tapos, meron tayong 6 ohm resistor in series dito sa parallel combination nitong capacitor tsaka resistor na merong negative J2 ohm tsaka 4 ohm resistance. Okay? So, hanapin daw natin yung power factor tsaka average power. So, dito muna tayo sa power factor. So, considering this circuit, pwede nating hanapin yung kanyang equivalent single impedance, Z. Right? Kasi kapag nakuha natin yon, yung pinaka-impedance angle natin is mahahanap din natin. Which is kapag hinanap natin yung cosine, equal na yon sa power factor. Right? So, sige, simplify natin to. So, yung pinaka-equivalent impedance natin is itong 6 ohm, naka-series dito sa parallel combination itong capacitor tsaka resistor. So, anong formula doon kapag meron tayong dalawang parallel component? Yung product nung impedance nila over yung sum nung impedance. So, therefore, we have negative J2 times 4 over negative J2 plus 4. So, using calculator, equal to saan? So, 6.8 minus J 1.6 ohm. Ngayon, kailangan natin yung impedance angle. So, convert natin to into polar form. So, pag kinonvert natin tong impedance in rectangular form into polar form, using calculator, ilan? 7 angle negative 13.24 degree ohms. Right? Ngayon, itong nakuha nating angle na to, siya yung impedance angle. So, kapag hinanap natin yung cosine ng impedance angle, siya na yung power factor. Right? So, therefore, power factor is equal to cosine ng negative 13.24 degree. So, using calculator, ilan ito? 0.9734. So, dahil capacitive tayo, leading power factor. Okay? Now, next requirement is calculate the average power. So, meron tayong formula na average power is equal to S times power factor, right? So, meron na tayong power factor. Itong S na lang. But itong S is equal siya sa VRMS times IRMS. Okay? So, meron tayong VRMS, right? IRMS na lang. So, paano natin makukuha ito? So, gamitin natin yung Ohm's Law. So, using Ohm's Law, IRMS is equal to VRMS over Z. So, nakuha na natin itong Z, right? Substitute na lang natin. So, yung VRMS equal siya sa 30 angle 0 degree over yung Z in polar form is 7 angle negative 13.24 degree. Okay? So, using calculator, in polar form, ano yung value ng IRMS natin? 4.286 angle 13.24 degree amps. Okay, so yung magnitude ng IRMS natin is ito. So, pwede na natin i-plug in dito sa P. So, average power is equal to VRMS, value niya is 30, times, yung IRMS is 4.286, times power factor na nakuha natin, right? 0.9734. So, using calculator, our average power is equal to 125 watts. Okay, so I think that's it for this video, apparent power and power factor. So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.